Hello, and welcome to the A-Level Chemistry presentation for the Heybridge Virtual Open Evening. My name's John Hall, I'm the Head of Chemistry, and I'm going to tell you something about the course that we offer here. Over the next 10 minutes, I'm going to provide some information about the course we offer and the benefits of studying the one true science. Chemistry performs a vital role in everyday life, some ways more obvious than others. It helps us explain the world around us, and it provides solutions to problems, some big and others small. Say hello to the team. These are the members of staff in the chemistry department. There's me, the head of chemistry, Miss Longville, Mr. Ted, who is also the head of science, and Mrs. Carpenter, who is also principal examiner, moderator, and assessment advisor for A-level chemistry at the AQA exam board, which means she writes, marks, and moderates the exam papers you will take at the end of year 13. So, what does the department look like? Here are some photos that show the areas that you will be studying in. We have 4 dedicated chemistry classrooms, one for each member of staff. The one on the right is my room. All of our classrooms are equipped with the facilities and the equipment to deliver the A-level course, and in particular, the practical elements that are now a required part of the course. Lessons involve a range of activities which are designed to support each student's progress and attainment. Our course is designed to support each student's transition onto the A-level course, taking into account their differing starting points, whether that be the differences between the combined and separate GCSE courses, or the slightly differing content of the different exam boards, so that each student is given the best possible opportunity to succeed at A-level. Ensure that lessons are enjoyable but productive. Make the content relevant to topical issues and link to content that has already been studied, whether that be at GCSE or earlier in the A-level course. Provide opportunities for stretch and challenge beyond the A-level specification in preparation for the demand of degree-level study at university. Progress is assessed each half-term to provide every student with individual feedback to support their own progress, to increase their attainment in preparation for the final exams. A-level is a marathon, not a sprint, and it might not always be easy, and there might be bumps along the way. Our course is designed for students to be ready when it counts, at the end of year 13, when the exams that matter take place. The A-level content is delivered through a structured course using lessons that involve direct instruction to deliver the knowledge by the teacher, modelling of the application of the knowledge also by the teacher, deliberate practice of applying the knowledge by the students. Experimental work is then used to embed the links between the theory and the practical techniques that form part of the A-level course. Our A-level course also features a highly structured programme of independent study to help students learn and apply the course knowledge and develop the skills that will be assessed in the external exams. The learning and application of the knowledge is achieved through the use of knowledge tests, exam question practice, and online resources such as Seneca. The skills are developed using a range of resources that focus on numeracy, extended response, multiple choice questions, and practical skills, and how they are related to the content and assessed on the exams. The keys to success in A-level chemistry, and in fact any A-level course, are listen and read carefully. Little things can make a big difference. Work hard but efficiently. Learn the content. Success is impossible without it. Pay attention to the details. Exam technique is incredibly important. And use the support available. You don't have to do it on your own. The A-level chemistry course is divided into 3 main areas: inorganic, organic, and physical chemistry. Inorganic chemistry studies the chemistry of compounds that don't contain carbons, metals and their compounds, for example. Organic chemistry studies the chemistry of carbon-containing compounds and includes the hydrocarbons studied at GCSE. Physical chemistry studies the use of measurements in chemistry. Each branch contains several different topics. In Year 12, these topics build on knowledge from GCSE. Inorganic topics include periodicity, Group 2, Group 7, and Period 3, which are linked to the periodic table content at GCSE. Organic chemistry topics include isomerism, alkanes, halogenoalkanes, alkenes, and alcohols, which build on the crude oil content from GCSE. Physical chemistry topics include atomic structure, bonding, energetics, kinetics, equilibrium, and redox, which build on the atomic structure, bonding, energy changes, rates and equilibrium topics from GCSE. In Year 13, the topics build on knowledge from Year 12. Inorganic chemistry topics include transition metals, which is linked to bonding and redox. Organic chemistry topics include aldehydes, ketones, carboxylic acids, aromatic chemistry, polymers, amines, amino acids, proteins, DNA, synthesis, and structure determination, which build on the organic chemistry work from Year 12 by increasing the number of different groups of compounds and analytical techniques studied. Physical chemistry topics include thermodynamics, the rate equation, equilibrium constants, electrochemistry, and acids and bases, where, for example, thermodynamics is linked to energetics, and equilibrium constants builds on the equilibrium topic from the previous year. There is also a required practical element to the A-level chemistry course. These activities are designed to develop a range of practical skills and techniques. All A-level chemistry courses contain the same 12 practical tasks that must be completed as part of the course, irrespective of which exam board specification is followed or where you study chemistry. These tasks are assessed in two ways. In the external exams at the end of the course, which determines the final A-level grade, and during lessons by your teachers to award a separate practical endorsement which focuses on skills such as following written procedures, using an investigative approach, recording, analysing and evaluating results, and research and reporting. These skills are the same for other A-level science courses, and a passing the practical endorsement usually forms part of the offer that universities make for a place on a science-related course. The awarding of the endorsement is monitored through visits by the exam board, and as a department we have a perfect record to the extent that the exam board requested that we share our good practice with other schools. In addition to the lessons that form part of the A-level chemistry curriculum, we also offer an open door policy for support to ensure students get bespoke support that is individual to their needs to aid their progress and increase their attainment, because a support session once a week at a specific time makes it difficult to provide the specific help to an individual student when many students may attend. There is an enrichment group to support students in preparation for applications to study medicine and other science-related courses at university. And we have links to local universities that have seen us attend lectures at Birmingham University and spend a day using the labs at Warwick to sample what studying a science at university is like. Here is a short video from the chemical industry giant BASF that shows how important chemistry is in our everyday lives.
We believe that if love is a chemical reaction, chemistry has a good chance to make the world a more harmonious place. Chemistry creates good relationships among the elements. It finds secret formulas to unite rather than separate things. It works so that experiment after experiment, bandages end up loving the water. Wheat can survive pests. Families are less afraid of energy bills. And even cars and city centers get along better. Chemistry ultimately creates good relationships between people and whatever they need in their lives. That's why we don't just make chemicals, we create chemistry. BASF, the chemical company.
Chemistry is an important, challenging and stimulating subject. When I was at school, it was the only subject that really made me think. You may be like me. Probably not. For some students, studying chemistry at A-level is essential. It is a must for some courses, such as medicine, dentistry and veterinary science. For others, it's a case that they enjoy chemistry at GCSE and want to study it further. And for some, it's a subject they excel in. For many, the decision to study chemistry at A-level is a combination of some or all of those reasons. But even if you have no plans beyond choosing A-level subjects at the moment, chemistry could be a good course to study because it is a facilitating subject that is also favoured by non-science related degree courses such as accountancy and law, and by highly respected universities, such as the Russell Group, because of the transferable skills that are developed through studying chemistry at A-level. Chemistry is central to the modern world economy due to its role in converting natural raw materials such as oil, natural gas, air, water, metals and minerals into thousands of different products that are fundamental in improving living standards. An increasing number of industries are turning to chemistry and employing chemists to improve their business in fields as diverse as medicine and meteorology, pharmacy and petrochemicals, and cosmetics and craft distilling. At Heybridge, we follow the AQA Exam Board specification for A-level chemistry, which was introduced in September 2015. We offer the full 2-year A-level chemistry course and do not offer AS chemistry as a standalone qualification. The content to the reformed A-level course that we offer is similar to that in the legacy specifications, but has an increased focus on a number of skills. Numeracy. Mathematical demand is assessed at GCSE 9 to 8 standard at the end of the course. Literacy. There are questions in the exams that require extended responses. Practical skills. The exams also feature questions on the 12 practical tasks that form part of the course. And multiple choice questions. These have also been introduced as part of the assessment in the external exams. The assessment consists of 3 external exams taken at the end of Year 13, the results of which determine the final A-level grade. In addition to the final A-level grade, there is also the practical skills endorsement, which is assessed by teachers based on practical tasks completed in lessons. This table shows the content of each exam. All 3 exams are 2 hours in duration. The first paper, Inorganic and Physical Chemistry, contains questions on the inorganic chemistry and some of the physical chemistry content. It is a mixture of short and long answer questions, similar in style to GCSE exam papers, and contributes 35% of the final A-level grade. The second paper, Organic and Physical Chemistry, contains questions on the organic chemistry and some of the physical chemistry content. There is some physical chemistry content that appears on paper 1 and paper 2. It is also a mixture of short and long answer questions, similar to paper 1, and also contributes 35% of the final A-level grade. The final paper, Practical Skills, Data Analysis and Synoptics, is a synoptic paper, which means it can contain content from any topic in the course. It also contains questions on the 12 practical activities that are part of the specification. It is a mixture of short and long answer questions and multiple choice questions, and contributes 30% of the final A-level grade. Here are some positive things that students have said about the A-level chemistry course that we offer here at Heybridge. So that's it from me. Hopefully you've decided that chemistry, the one true science, is the subject for you, and I hope to see you in September when we start our course.